Now the question is, now that we have this expression for the Gibbs energy as a function of the fugacity, how do we actually determine fugacity values? Well, it says here fugacity is a function of temperature and pressure, and that is true. So this is something, if you are needing to use fugacities, it's usually something you're going to go look up in a table. What is the fugacity coefficient, which we'll talk about in just a second. Basically, it's how you scale the pressure. But how do we actually do this? Well, the first question we need to figure out is, if we want to use this equation, we know what's F naught. And so to be able to keep our analogy with the ideal gas, F naught has to be the same as P naught. Otherwise, these equations are not equivalent, because this value, this G, standard G value, is for the standard pressure. So F naught is the same as P naught, which is 1 bar, and it's 1 bar of ideal gas. So we have to say specifically this is an ideal gas. Okay, so that's true for both these equations. So F naught and P naught, the standard state pressure is 1 bar ideal gas. Some other properties of fugacity we would like, or we sort of have to have, the fugacity will approach the value of the pressure as pressure goes to 0. All right, so as we get closer and closer to ideal gas conditions, as we decrease the pressure, because typically we're using this at very high pressures that we need fugacities, the fugacity should behave just like a pressure, and we should come back to our ideal gas version of the equation as the pressure gets lower and lower. So that's another property of fugacities. Okay. And so how do we actually calculate? So we sort of have determined the other parts of this equation, but what's the process for actually determining fugacities? If you were to go look this up in a table, how did these values come to be? Well, let's think about an imaginary reaction here. And the nice thing about state functions and thermodynamic functions is that even if reactions are imaginary, you can still do calculations with them. So let's imagine we have the Gibbs free energy of our real gas. Real gas meaning it doesn't follow the ideal gas law. And that will be at some given temperature and pressure. And what we need to know is what's the difference between the real gas behavior and if theoretically this gas behaved under ideal behavior at the same temperature and pressure. Now, that's not what would actually happen, but this is a theoretical exercise. There's some difference in molar Gibbs energies here. We'll call delta G1. And if we can find this difference, then we can figure out how to look at the difference between pressure and fugacity. So, okay, by definition, delta G1 has to be equal to G bar ideal minus G bar real. That's sort of why we defined it this way. And then we have expressions for the ideal gas behavior and the real gas behavior, right? We know the ideal gas behavior is G naught at our given temperature plus RT log P over P naught. So that's the expression that we looked at earlier. And for the real gas, we have the same expression, but now we have fugacities instead of pressures. Okay, and so that is our expression here. Now we can go ahead and simplify this a little bit. Our G naughts are the same for both of these cases. So we will get RT log P over P naught minus RT log F over F naught. But remember, P naught and F naught down here, these are the same. So we can simplify this even a little bit further by separating out our natural log terms. So we'll have an RT log P minus RT log P naught. That's just rewriting this term here into two terms, minus RT log F plus RT log F naught. And these two terms are going to cancel. And then we can recombine this term and this term into one term and say overall this delta G value is RT log P divided by F. Okay, and that is, we're going to put a 1 next to this. This is equation 1. Okay, so that's nice. Now we have an expression that has pressure and fugacity in it, but we need something that doesn't have fugacity in it, so we can actually calculate it, right? And so what we're going to imagine here is we're going to use the fact that we have a state function in the Gibbs free energy and get a different way of getting at this function. So we'll have g bar real at T and P, in this imaginary process by which it becomes an ideal gas at the same temperature and pressure. Which again, this is all theoretical, it's not an actual thing you can do. But let's imagine we have an alternative process, right? And this has delta g bar 1. An alternative process has its own changes in Gibbs energy where we decrease the pressure to some arbitrary value where P approaches 0, so that fugacity and pressure are equal, right? At that point, g bar real equals g bar ideal. At some point we lower the pressure enough that the gas behaves like an ideal gas. Okay? And then keeping it at an ideal behavior, we increase the pressure again to get back to this imaginary point of the ideal gas under that higher pressure again. All right? So this is an alternative way of getting here. So in the next video, we'll look at what are these other two delta G expressions and how can we use that to find the fugacity.